So in 4.5, we only have one goal for the end of the lesson. We should be able to solve basically any quadratic equation that may not be factorable. Let's recap so far what we've talked about. We talked about using factoring to solve quadratic equations. The idea is if a quadratic equation, which is in standard form, and it has to equal 0, that's important, is factorable. For example, two pieces multiplying together equals 0. Then in order to solve quadratic equations by factoring, you just set those individual pieces equal to 0 and solve. Another thing that we talked about, and this was yesterday's lesson, if your equation only has an x squared term, you can use regular algebra. To solve. For example, if I had something like 5x squared minus 7 equals 3, I can use regular algebra to solve this. I don't have to use factoring. I don't have to use any fancy techniques. Or stuff like, 4 parentheses x minus 2 squared plus 1 equals 9. I can use regular algebra to solve this guy because there's only one variable term. Today we're going to look at equations that have that is in standard form that has both an x squared and an x term that we can't factorize. Now, just a little sort of disclaimer here. I hope by now in Algebra 2 we have all heard about the quadratic formula. The quadratic formula says this: for any quadratic that's in standard form and it equals 0, the solutions x will always equal opposite b plus or minus the square root b squared minus 4ac all over 2a, where a, b, and c are the coefficients and constants of your equation. Now, if you don't want to pay attention or listen to the rest of the lesson, you can get by with this formula. This formula will solve any quadratic equation you want, factorable or none. The only problem is it's a little bit tedious. It does take a little bit of time to plug in and do the mathematics, and you always have to simplify your radical expression. If you're up for it, if you don't care to learn different techniques and methods and you just want to use the quadratic formula for the rest of this lesson, congratulations, you know 4.5 already. So I guess you can just shut down the video and just keep doing quadratic formula over and over and over again. For the rest of us that sort of want to talk about this new technique or this other technique, what do me personally, Mr. Vo, use if my quadratic is not factorable? So this is the idea. If I only use it for certain situations, if your quadratic has the following conditions, it needs to be not factorable. The leading coefficient is a positive 1. The leading coefficient is the number in front of the x squared. And the linear coefficient, the middle number, or the number in front of the regular x term, however we want to think about it. The linear coefficient is the middle number or the number from the x term. The linear coefficient is even. Right? So if all of these conditions are true, the leading coefficient is 1, the linear coefficient is even, then we can employ this technique called completing the square. Then completing the square may be a way to solve. to solve. Well, before we get into completing the square, I sort of want to talk about the idea behind it, where it comes from. What is completing the square? Well, the idea comes from squaring a binomial. Well, what do I mean? Well, let's just do a few examples here and see if we can recognize a pattern. If I were to take, say, x plus 2 and squared it, right? And I did the math and I squared it and I got an answer. That would give us x squared plus 4x plus 4. What if I did x plus 3 squared? No, you expanded it, you multiplied it, did some math. You'll get an x squared plus 6x plus 9. What if I did it with a plus 4? You get an x squared plus 8x plus 16. And it doesn't have to be pluses. I could do it with minuses too. What if I did an x minus 5 squared? That'd be an x squared minus 10x plus 25. What about an x minus 6? X squared minus 12x plus 36. What if I was doing an x minus 7 squared? X squared minus 14x plus 49. Now, I didn't memorize these products. I didn't do it beforehand. The reason why I did this fairly quickly and easily is because squares of binomials, they always come in this in a particular pattern. Let's see if we can't find a relationship between the numbers in the parentheses with the numbers in the standard form, in the expanded form. Well, let's take a look here. There's something we should notice. The number that's in the parentheses is always half of the linear coefficients. It's always half of the middle numbers. Let's see if I can't color code this. Yeah, I think you guys can see that. The yellow is always half of the red. Now, how does the yellow relate to the constant, the number at the end here? Notice how the yellow is always the square root of the pink. Or in other words, to say it the other way around, the pink is the yellow squared. And it's true whether or not we have positive or negative. We can see here that indeed in these examples, the orange or the red is always twice as much as the yellow, and the pink is always yellow squared. And that's sort of the relationship that we need to be able to see when it comes to squaring a binomial. So let me go ahead and write this all down using color code. The yellow here is always, let's go ahead and write some observations here. Why is this small? Okay. Observations. The yellow is always going to be 1/2 of the red. I hope we can see that. In the first line, 2 is half of 4. 3 is half of 6. And it could be the negative as well. 6 is half of 12. So when you square a binomial, the yellow is always half of the orange. And we also said that the pink is always the yellow squared. Right? 9 is 3 squared. 16 is 4 squared. 49 is 7 squared. Well, what these two observations allows us to do is it creates a bridge or a relationship between the numbers inside of the parentheses, the yellow numbers, to the coefficients of your standard form, the red and the pink. If we were to put these two ideas together, what it says is to figure out the constant of a perfect square trinomial. Now, if you don't know what the constant is, the constant was the pink number. To figure out the pink number, you would take half the middle number and then square it. Right? And we should see that relationship in our two observations. What would happen if I were to take this yellow here and put it inside of that yellow? What that tells us is these two guys together tells us that the pink is equal to 1/2 of the orange squared. So now we have a relationship between the numbers in the standard form together. Well, how does that help us? How that helps us is that it basically allows us to transform any unfactorable quadratic into something that's a little bit more factorable, at least part of it. Well, once you factorize something, at least part of it, you can just use regular algebra to solve. I think this would make a lot more sense if we did concrete examples. Let's take a look at an example here. Suppose I ask you to solve x squared plus 14x minus 31 equals 0. Well, of course, the first thing I would try to do is factorize this guy using those two parentheses. But guess what? This guy is not factorable. And a little spoiler alert, I think most, if not all of your practice problems in this section will not be factorable. So, okay, gee, I can't factorize this guy. What can I do? Well, as I said before, you could use a quadratic formula, and that's what you want to do, be my guess. But let's notice some observations here. Notice we have something that's not factorable. The leading coefficient is 1, right? Yep, the leading coefficient is 1. And is the middle term even? Is the middle number even? Yes, we do. Have it. 14 is even. So we can go ahead and try to do completing the square. And this is how it goes. What you want to do is get rid of the regular number because we want to fill in our own number there. So the first thing we're going to do is add 31 to both sides. But what I'm going to do here is I'm going to deliberately leave a gap because I'm going to fill something in this gap here. Well, what am I going to fill? To complete the square is to figure out what this pink number is. Right? In this above relationship, to complete the square is to figure out what these pink numbers are. Well, how can I do that? We have this equation here. The pink number is just half of the red number squared, and the red number was the middle guy. So, what is this magical number? Here's scratch work here. Or actually, I'll do this in black. Some scratch work. What you want to do is you want to take the middle number, which is 14. You want to take half of it, and then once you do that, you want to square it. So 14 divided by 2 is 7. 7 squared is 49. So this 49 here is what you're going to add. But of course, this is an equation, right? And what you do to one side, you have to do to the other. So I have to add a 49 to the right-hand side. Now, why would I bother going ahead and do that? It looks like I made the problem bigger. Well, notice the left-hand side now is factorable. And here's the cool thing. The factoring pattern is always the same. It's going to be parentheses, whatever the variable is, in this case is x. Whatever this symbol is, if it's a plus, we write down a plus. If it's a minus, we write down a minus. And then it's going to be half the middle number, close the parentheses squared. Every single time. Once you get in the hang of this, it's sort of automatic. You don't have to think about it anymore. Variable, same symbol, half of this number, squared. And of course, the right-hand side is an 80. And then notice what we have here. This problem was just like 4.4. These are the problems you saw yesterday. So to go ahead and solve this guy, just go ahead and take a couple of quick square roots. X plus 7 equals, we're taking a square root, so we need a plus or minus. And then one last step to solve for x, I'm going to subtract 7 from both sides. So you have x equals negative 7 plus or minus the square root of 80. We have solved it without using the quadratic formula. The only other thing I would say to you guys is make sure if you have any radicals to simplify them as much as possible. That's the factor tree. So here's my scratch work again. I want to simplify radical 80. So I know that's 8 and 10. That's 4 and 2. That's 2 and 5. And I know 4 is 2 and 2. So I'm going to look for doubles. I got a double here. Actually, let me color code this. I got some doubles here. So that equals a 2. I have another double here. So that's a times a 2. And I do have this 5 that's left over. So that's inside the radical. So altogether, this is 4 radical 5. So my final answer would be negative 7 plus or minus 4 square roots of 5. So you can see how completing the square, I think, makes solving unfactorable quadratics solvable in a fairly simple manner. The hardest part of completing the square is to figure out this number here. That's what basically completing the square is. It's doing a puzzle. What magical number do you have to add in order to sort of unlock this problem? And the pattern is always going to be the same. It's always half the middle number squared. Let's just do a handful more examples until you get the hang of things, until you get the flow of things. Let's go ahead and let's solve x squared minus 4x minus 36 equals 0. It's important. It has to equal 0, so if the equation doesn't equal 0, you're going to have to move things around. Again, the first thing I would always try is to factor him, but spoiler alert, none of these will be factorable. So I'm going to go ahead and complete the square. I know I can, or I know it's easiest because look, the leading coefficient is 1, and the middle guy is even. So let's complete the square. So we want to get rid of this guy. We want to make room. So I'm going to add the 36 over. That leaves a gap here. And I need to add something into the spot here. So scratch work. What I add is going to be half of the numbers, the middle number. So the middle number is 4. You don't care about the minus yet. You want to take half of him, and then you want to square him. Well, that's going to give you a 4 right back. So I need to add 4 to the left, but what you do to one side, you do to the other side. By adding the right number to the left, this guy's factorable. And remember, you don't have to do any thinking. It should be automatic. It's going to be variable, same sign, half of this number, parentheses squared. And then, of course, you do the right-hand side, which is a 40. Then you just do 4.4. You do yesterday's lesson. Solve this guy. I'm going to take a square root. X minus 2 equals plus or minus. You always need that plus or minus when you take a square root to solve. And the last step is to add the 2 to both sides. As always, you want to see if you can simplify the radical. I have a 4 and a 10. I have a 2 and a 2. So I got a doubles here. And 2 and 5. Nope, this doesn't work. So then I just have the 2 and the 5 left over. So all together we have 2 radical 10. X equals 2 plus or minus 2, radical 10 should be the final answer that I'm going to accept. We need to be comfortable with simplifying. If we do not simplify, unfortunately, I'm going to have to mark it off wrong. So that's completing the square. Completing the square is just solving a puzzle, figuring out what special number I would have to add to unlock the problem. Again, I would only complete the square if it's not factorable, the leading coefficient is 1, and the middle term is even. If any of those cases were not true, right? For example, x squared plus 5x minus 3 equals 0. Because this guy is odd, I would use the quadratic formula. What if I had something like 2x squared plus 8x plus 3 equals 0? Well, this guy is even, so that's good, but leading coefficient is not 1. I would use the quadratic formula. So those are just my hints to you. I would use completing the square, use this technique if the leading coefficient is 1 and the middle term is odd. If any of those cases aren't true, just go ahead and use the quadratic formula. So that's it. That's completing the square. That is actually my, Mr. Vo's, personal favorite way to solve a non-factorable quadratic whenever possible. If these 2 examples aren't enough, if you want to see more examples, please, please, please let me know, and I will gladly show you this as many times as necessary. But have at it, give it a shot, and good luck.